here are the answers to the slides for single replacement that are in your digital notebook. So if you want to try these slides in your digital notebook first, and then you can use this to come back and check the key. So in order to complete this, these two slides, you will need your yellow packet that has your activity series of metals chart. We need that list in order to figure out which metal is most reactive or if a metal is strong enough to replace another one. So out of these examples, we'll do the first one even though it's done for you. You're comparing magnesium or barium. So if you find magnesium on your list, it's kind of in the second box for the activity series of metals. And then if you find barium, barium is closer to the top. So because barium is closer to the top of the activity series means that metal is more reactive. And so that is the one that we would circle. Part B, we're comparing calcium and iron. So calcium again is kind of towards the top. Iron is more towards the middle. So since calcium is above iron, calcium is going to be more reactive. The third set, part C, sodium and potassium. These are going to be closer to the top. Potassium is above sodium on the activity series list, so potassium is going to be more reactive. All right, the next set, lead and copper. These are going to be towards the middle or towards the bottom. So lead is above copper on the activity series, so lead is going to be more reactive. And the last set, platinum and silver, these are both towards the bottom. Neither platinum or silver is very reactive at all, but silver is above platinum on the activity series list, so silver will be slightly more reactive. All right, so on this slide, you are figuring out if the reaction will happen or not based on the metal's position on the activity series. So these are all single replacement reactions. If the reaction will happen, you put a green check mark in the box and you predict the products and balance the equation. If the reaction will not happen, you put a red X and that's it. Because if the reaction doesn't happen, it's not going to form any products. So for the first example, we are comparing copper to silver. So you would find copper and silver on your activity series. Copper is above silver. So if the single element, which is copper, is above the one that it's trying to replace, this reaction will happen. So we'll put a green check in the line, and then we will need to predict the products. I apologize, I should have added copper has more than one charge, so for this one, let's go with +2. So copper, which is +2, is going to replace silver. So when the atoms rearrange, copper is going to combine with nitrate. When you form a new compound, you have to go back to the basics and balance out the charges. So if copper is +2 and nitrate is -1, we need 2 nitrates to balance out the charges. And then silver gets kicked off by itself. So silver will be out here by itself. All right, so once we have the charges balanced, then we can balance the number of atoms on each side of the arrow. So on the reactant side, we have 1 Ag. On the product side, we have 1 Ag. On the reactant side, we have 1 nitrogen. On the product side, we have 2 nitrogens. So I'm going to put a 2 in front of the Ag, NO3. That 2 now will change the number of silvers, so we need to put 2 in front of silver. Here we have 2 nitrogens, and here on the reactant side we have 6 oxygens. And on the product side, we also have 6 oxygens. So silver is balanced, nitrogen is balanced, oxygen is balanced. Here we have 1 copper, and on the product side we have 1 copper. So that would be our complete balanced equation for the first reaction. All right, so for the next one, we are comparing silver and copper again. However, this time silver is our individual metal. So find silver and copper on your activity series list. Silver, which is our single element or our single metal, is below copper, which means that silver is not strong enough to replace copper. So then all we have to do is put an X and say no reaction because nothing will happen. All right, number 4, we're comparing aluminum with hydrogen. So if you find aluminum on the list, it's kind of closer to the top, where hydrogen is below it. So if the single metal is above the one that it's trying to replace, this reaction will go. So we're going to put a green a green check mark on the line. And then now we'll have to form our products. So aluminum, which is +3, is going to replace hydrogen, so it is going to combine with sulfate. And sulfate is -2. So first we have to balance out these charges. So 2 and 3 both go into 6, so we would need 2 aluminums and 3 sulfates. I'm going to erase these charges real quick. All right, and then hydrogen now gets kicked off by itself. So this would be our skeleton reaction, and now we would have to go back and balance the number of atoms on each side of the arrow. So on the reactant side, we have 1 aluminum. On the product side, we have 2 aluminums. So we're going to put a 2 here in front of aluminum. Here we have 3, here on the product side. Sorry, my pen shut off. Okay, here on the product side, we have 3 sulfurs. Here we only have 1 sulfur, so I need a 3 here. This 3 now means that we have 6 hydrogens, so I need to put a 3 here. The 3 on the reactant side that we put in front of the H2SO4 means that we have 3 sulfurs, so sulfur is balanced out. But now we have 12 oxygens. So here we also have 12 oxygens. So this should be your final balanced equation. All right, so let's look at the next one. We are comparing nickel and zinc on your activity series. So find nickel, find zinc. Zinc is above nickel. So since nickel, the single element, is below the one that it's trying to replace, this reaction will not happen because nickel is not strong enough to replace zinc.